Once you click on the link, we will download the latest data. This is Control F 2023. Click on type in search, Control F. The search window will open, type Dallas, DALLAS, Control F, Dallas. Got it? In Dallas, download listings.csv. Download listings.csv. Control F, type Dallas, DALLAS, and then download listings.csv and also reviews.csv. Listings.csv and reviews.csv. Two files you have to download for Dallas. All right, Chandana, what is your email? Can you type your email ID in the chat window, please? MIPL also. Share your email ID. Comma separated files. CSV files are comma separated files. Most of the times in data, we use comma separated files. CSV files are the default download format for databases. When you download data from a database, it will be downloaded as a CSV file. If it is very large file, it will be downloaded as TSV, tab separated. CSV is comma separated. And most of the times we take input in Python and Data CSV files. You can create a folder on your system and you can save the files into that system. So create a folder which will be your working directly for both Python and R. So all your data sets which I forward you will be saving in those folder. It can be anywhere on your drive, C drive, D drive, or anywhere you can save, desktop, wherever you want. Create a folder. Whatever data sets I share will be saved into that folder. And we will use that folder path in our importing of data sets in Python. So whatever downloaded files, you move them from downloads to the particular folder. All right, all of you got the files. Open the file listings.csv. Go to file, because see, CSV file is a single sheet file. Excel is a workbook. In CSV, you'll have only one single sheet. So even if you open multiple sheets, it will not save them. Ultimately, when you come to saving, it will not save the additional sheets. It will not save the visualization. So we need to convert the CSV to Excel workbook. Choose the location where you want to save and then save as type. Choose the first option, Excel workbook. Save as type. Choose the first option, Excel workbook. First file, save as. Choose the location where you want to save, the folder or the drive. Then file name, save as type. Click on save as type. Choose the first option, Excel workbook. Choose the first option, Excel workbook. Click save. It will save it as an XLX workbook. Google Sheets, no problem. All right, got it? Got it, all of you? Any doubts? Please don't hesitate. If you have any doubts, please give me a call. I'll come and correct it, okay? You don't need to come here. I will only come to your system for any doubts and clarifications and errors and mistakes. And most of the times, mistakes will be spelling mistakes. Please be sure. I'll tell you how to do the auto-filling. You will eliminate all the mistakes. Now, whenever we get any data, first step is, whenever you get any data, first and foremost step is exploratory data analysis, also called as exploring the data. To understand the data, we have to do this. Exploratory data analysis is the first and foremost step you have to do when you get data to you. Or any software, whether you're using Excel, Python, R, SAS, or any analysis software, the first step is you need to understand the data, right? Know what you are dealing with. So how will you know? By performing this ED or exploratory data analysis. Now, this exploratory data analysis have three. Step one is descriptive statistics. Descriptive statistics. Step two, data visualization, data aggregation, or wrangling. Exploratory data analysis includes three steps: statistics, data visualization, data aggregation, or wrangling. After performing these three steps, you will completely know or understand the data and its trends. What is the data you're dealing with? What trends, what patterns it has? All those things will be understood by doing this. And the EDA has three steps: descriptive statistics, data visualization, and data aggregation. So any data science project, we start with the EDA process using any software. And even the automated softwares, AutoML softwares also, first they do EDA only using these. Now let us understand the first one, the descriptive statistics. Descriptive statistics, we start basically with count, or N, or small n. Count means number of rows or observations. Number of rows, or we also find out the number of columns or variables. We also need to find out how many columns or variables are there. N or capital N. See, generally in statistics or capital N or small n represents number of observations. In statistics, capital N or N represents rows or predominantly capital N. In some textbooks, they use small n, but count or N means number of rows or observations. Because generally the data we deal with will be in a data frame format. So these are our variables, right? 23 male, 26 female, urban, 28 male, rural, 27 female, rural. So these are observations. These are variables. Horizontal are your rows are observations. These are what also called as variables or columns. Excel, we call this as data table. In Excel, we use in data science, we use the word data frame. Data frame is and columns are attributes or variables. We will use the word variables. Variables, attributes, features, they are all same. Variables, attributes, or features means same, synonyms. But we will be referring to them as variables. Rows are observations, columns are variables. That is the data frame structure, also referred to as data table. Also referred to as data table in Excel. Now, the other descriptive statistics also we need to know. The maximum range is what? Max minus min max. Minimum, maximum of each variable. What is the minimum of each variable? What is the maximum of each variable? And also the range. The formula of range is maximum minus. We need to know the range of the data here. So count, min, max, and now after this we'll start our the major descriptive measures of central tendency means the word central tendency means measures of central tendency. Central tendency means also called as average, because in Excel we don't have mean function, right? In Excel we have average, mean or average, median and mode. All these three will be giving us the midpoint of our data. Midpoint of our data. Now these two are midpoint of data. This is most. So how do you calculate mean? Sigma n divided by sum of numbers divided by n means count. Sigma n means sum of the values divided by, how will you calculate median? Sort data in what order? Ascending order. The first step is you have to sort data in ascending order, right? Then if the number of observations is even, you will have two medians, m1 plus m2 divided by 2. If n is odd, exact midpoint. The exact midpoint will be your, in odd you can separate, right? Equal number of down, you can separate even and then you find the mean. If it is even, you have two medians, m1 plus m2 divided by m1 plus m2 divided by 2. And mode is anyway most frequent. You will count how many times each of them will repeat. Now, one important thing now you understand in central tendency is we have to always, whenever you're calculating mean, median also must be calculated. Why? Because mean tends to be distorted. Smaller values are larger. We call this as mean distortion. Mean gets distorted by smaller values and larger values. That is why we have to be very careful. That's why whenever you calculate mean, you should also calculate median. In all summary statistics, you will also get mean and you also get median. Now, both of them should be closer to one another. Not that they should be exactly same, but they should be closer to one another. Very close to one another. If the distance is far, take for example, you got mean of 100 and median of 180. That means mean is getting affected by smaller values or larger values. Take for example, I have conducted a test table score like this: 60, 65, 90, 91, and 90. 63 plus 65 plus 90 plus 91 plus 92. I got 401 n. That means 401 divided by 5. 82 point, how much? 401 divided by 5. 80.2, sorry. Now the average is 80.2. Is it giving you the correct reflection of this data? Is it giving you the correct reflection of this data? Because majority of the students scored above 90. But your mean says it is 80.2. Now, if you calculate median for the same data, the data is in ascending order. You remove this 2 and you remove these 2, 90 will be your median, exact midpoint. So median is 90. So which is better here? So that's why we always need to compare mean and, because if mean gets distorted or mean is giving you wrong information about wrong pattern of the data, you will consider median as your midpoint. You will consider median as your, got it? Because mean gets affected. What is affecting mean? These two lower values are affecting the mean. So in this scenario, median is the right representation of data. So whenever you calculate summary statistics, you get median and mean both as output. You need to check both of them. They should be closer to one another. How much closer you will gain as we look at different data points. Now, median is also called as Q2 or median is also called as Q2 or second quartile, or median is also referred to as 50% Q2 or second quartile. So median is also 50% Q2 or second quartile. The second is measures of dispersion. What is dispersion? Dispersion is scattering or spread of observations. Scattering or spread of observations around. Dispersion means scattering of observations around mean. Scattering of observations around mean. The primary metric is also referred to capital S. The formula is sigma x minus mean whole square divided by n minus 1 for sample or n. N minus 1 or n. N minus 1 is what? If you are calculating population variance, the denominator will be n. If you are calculating variance of a sample, it will be n minus. Across statistics, n minus 1 represents sample, n represents population. And in Excel, you will see dot p, dot s. Dot p represents population, dot s represents n. Is in Excel, we will see dot p, function name dot p, n minus 1 represents, in Excel, we will see the function name followed by dot s. Var dot p, var dot s, ev dot p, std ev dot s, q dot p, q dot s. Dot p represents population, that means the denominator is n. Dot s represents sample, that means the denominator is n minus 1. Next comes your standard deviation, referred to as sigma or s, square root of sigma x minus mean whole square divided by n minus 1 or n. X bar represents mean. X bar or mu. X bar or mu represents, in formulas, x bar or mu represents. So mean is represented by x bar or mu. Mean is represented by x bar or. What should you understand from here? Here the primary metric is there is no fixed range. Lower the standard deviation, is better. There is no fixed defined range, but lower the value, the better. Lower the value. Now, it depends on the mathematical unit of your data. 20, 40, 60, 70, data in tens, plus or minus what we look for in standard deviation. If your data is in hundreds, plus or minus 20 or 10 to 20%. If your data is in thousands, plus or minus 100. If it is in 10,000, plus or minus 1,000. If it is in lakhs, plus or minus 5,000 to 10,000. So these are all judgmental calls which we will gain understanding as we work with different types of data during the, because when you don't have a fixed range, you have to make a call. You have to decide whether it is a higher value or a lower. There are other methods also which we will discuss. Accordingly, we will decide whether it is higher or low. But there is no fixed range. The better is the standard deviation. Then comes your measures of location. In the measures of location, we have quartiles, percentiles, and deciles. Where your data point is located. Quartiles divide data into exactly 4 parts. 25%, 50%, 75%, and you also have 0% and 100%. We are not bothered about. Quartiles divide data exactly into 4. 25% first quartile n divided by 4, or 50% or second quartile or median 2n divided by, or 75% third quartile 3n divided by 4. 3n divided by 4. First quartile, second quartile, and third quartile. So your data point like exists in which part of the data will be known using this quartile. And Q0 is minimum of that particular data, and Q4 is Q0 is the minimum of that particular data. Q4 is the maximum of that particular. For this also, I forgot the most important task. Sort data in what order? Ascending order. You have to sort data in ascending order. You have to sort data in ascending, then only you will know the location points. Sort data in ascending, and then you will be. So for median and quartiles, you have to sort the data into ascending order. For median and quartiles, sort the data into ascending order. Now, since quartiles divide the data into exactly 4 parts, we have something called percentiles. In percentiles, you can specify the exact percentage in decimal form. One of the common thing is top 20% customers. Generally, we have this concept of top 20% or bottom 20%, right? So 0.20 decimal. You have to give it the top or bottom. So similarly, sometimes you want to understand 80% of top 80%, 80-20 Pareto rule. So 0.80. So sometimes you need to have a specific percentage. You need to have a specific percentage apart from 25, 50, and 75. That time we have to use this percentile. And the percentages must be specified in divided by 100. You take the decimal value, right? And similarly, percentage deciles. Deciles is multiples of 10. 10, 20, 30, 40, 50, multiples of 10 is your deciles. Any doubts, participants? Then comes your measures of asymmetry. It means how close data is to normal distribution, also called as asymmetry. The word asymmetry means how close is data to normal distribution or bell. So you might remember this, right? Normal distribution or bell curve. Mean 0, standard deviation 1. And you have a positive standard deviation and negative standard deviation. I'm just giving you a rough. This is bell curve, which is also called as normal distribution, also called as Gaussian. A statistician named Gaussian has defined this. They are discovered this. In asymmetry, we have two things. The formula is x minus mean cube, sigma x minus mean cube divided by standard deviation. X minus mean, sigma x minus mean cube divided by standard deviation. Now, when you look at skewness, we are bothered about the positive sign. Positive skewness, the peak of the curve will be on the left side. Positive skewness, the peak of the curve will be on this side. In the normal distribution, it will be in the middle. The normal distribution, the curve will be on the peak. Sorry, the peak is on positive skewness. The peak is on left side. Negative skewness, the peak is on the right side. And if skewness is zero, normal distribution. See, normal distribution is always a hypothetical situation. What is a hypothetical situation? It does not exist in real life. So positive skewness, the peak is on the left side. Negative skewness, the peak on the right side. All normal distribution. So the mathematical sign is important. For skewness, you always look at the mathematical. The other part of asymmetry is sigma x minus mean to the power of 4 divided by standard deviation to the power of 4. Positive kurtosis greater than 3, the graph will look like this. Tall and narrow peak greater than 3. The value we have to look in here is 3. Skewness is 0. Greater than 0 or less than 0. Positive and negative. Here we have to take it as negative kurtosis less than 3 and wide, flat and wide, tall and narrow peak, flat and wide peak is equal to 3 normal distribution. Is equal to 3 is normal. Is equal to 3 is your normal distribution. See, this is equal to median is equal to normal distribution. Mean is equal to median is equal to CN. This is the other two. This is what? Negative kurtosis. Negative skewness. Positive skewness. This is positive skewness. The peak on the right, negative. The peak on the left, positive. Peak on the left is positive, peak on the right. Always remember peak. Peak on the left, positive, peak on the right, negative. See, kurtosis. Positive kurtosis is also called as leptokurtic. Mesokurtic is normal distribution. Flat and wide peak is tall and narrow peak, positive. Flat and wide peak is equal to 3, greater than 3, less than 3, equal to. The Excel functions for descriptive is equal to count, and data is equal to mean, equal to max, open bracket, is equal to average, open bracket, data, open bracket, data is equal to var, is equal to std, is equal to stw, is equal to cut. Function name. In Excel, the default syntax is function name followed by parenthesis. Is equal to, first you have to give is equal to, followed by the function name, followed by parenthesis. Parenthesis or round bracket. Here you give the data. So is equal to, the function always starts with equal to, followed by the function name, followed by round brackets or parenthesis. Within the parenthesis, you give the data reference. Is equal to quartile data array 0.25. All software you have to be 0.25. Latest Excel you need 1. Is equal to quartile data array, comma 0.50 or equal to quartile data array, comma 0.75 or if you want specific percentage, equal to quartile data array, comma 0.80. You can specify the required percentage, 88, 82, 83, anything you want, you can specify it as specific decimal value. Now, for data selection, you have to be very careful in Excel. Data selection. Control plus any of these arrows. Go to the first cell of your data. Control plus shift plus down arrow. Now you have to press arrow only once. Press arrow only once. If you press it 2 times, it will go to the end of the sheet. It will go to the end of the sheet. Go to the first cell of your data. Control plus shift plus either down arrow, up arrow, side arrow, anything. If based on requirement, you will press only. If you press it, but it will automatically go to the end of the data. Automatically go to the end of the. If you press the arrow 2 times, it will go to the end of the sheet. Okay? Control plus shift plus down arrow or up arrow or side arrow or anything. Press only once. It automatically selects the data range. Automatically selects the. So remember this thing, because when you're dealing with 10,000 lakhs of rows of data, we can't scroll down or like that. We have to use these arrows. Control plus shift plus down arrow will automatically select the data range. So let's go back to our data sheet, the Excel sheet. Now, column J is the price column. Column J is your price column. Column J is your price column, right? Go to the price cell. Control plus shift plus down arrow. Control plus shift plus down arrow. So we have 5,796. Control plus shift plus down arrow will select the data range. Control C. Click on a new sheet. Go to the first cell. Control V. Go to the first cell. Control V. Copy paste the data. Select the price. Control shift down arrow. Control C. Go to the new sheet. Click on the sheet plus sign below. Go to a cell A or something like that, and then Control V and Control S. Got it? Okay. Google Sheets. Google spreadsheet. Google spreadsheet. You have to press sign with Google. Alright. Now we'll calculate the descriptive statistics, deviation, interquartile range, which is nothing but Q3 minus interquartile range, Q3 minus Q1. Third quartile minus first quartile, we call it as interquartile range. Variable name is price. Excel is very important because all the algorithms will calculate the theoretical part in Excel only, except for the ensemble methods. Rest of all algorithms, right from regression, logistic, decision tree, all manual calculations will be done using Excel. So Excel is compulsory and mandatory. You might have learned using things like VLOOKUP, XLOOKUP. We might use data cleaning. In statistical analysis, we will be using. Now, first, let us find the data range. What is our data array or data? You can find it because see alphanumeric, right? In Excel, every cell has an address. Every cell has an address in Excel, which is alphanumeric. alphabet first, numeric. Now I'll go to the second cell below price because we can't use text in Excel. We can only use numbers. Go to the cell C2 and Control Shift down arrow. Control Shift down arrow. Now you can see the last observation is 5796. The last observation is 5796. Right? So our data range is C2 colon C5796. This is our data range or array. The data range or array is C2 colon C5796. You can type any alphabets can be small letters. Excel will auto-correct it. My column is C. Whatever you have taken, that alphabet will be your column. Right? My column is C because I put data in C. Whatever alphabetic column you have taken, take that alphabet. Go to the comma price is equal to, like I told you, the function name starts with POUNT, or once you type the first three letters, it automatically prompts. Double click on the prompted value, it automatically gives you the bracket, COUNT, open round bracket, type C2 colon C5796, close bracket. You can select also, but every time selecting you might miss out. So always best practice is write down the data range and start typing. Is equal to COUNT, open round bracket, C2 colon C5796, press enter. So this is the formula for count. You can check your notes, you can run other functions also. Is equal to min, is equal to max, range is maximum minus minimum, is equal to average, is equal to median. Maximum minus minimum. This cell minus this cell is equal to min, open bracket, C2 colon C5796, close bracket, enter. Is equal to max 5796, close bracket, enter. Range is equal to maximum cell is equal to check the notes. Is equal to, I have given all the functions in the notes, right? And all if you didn't try it. See, typically either the full name or the first three letters. Either full name or the first three letters will be the name of the function. Is equal to AV. Always give column gap between calculations and data. Always give a gap between the calculations and data. Don't type side by side. See, one column gap has to be there. Because if you solve this data, this also will get solved. So if you give a gap, this column will get solved. Minimum to maximum or something like that. So always keep a gap between calculations and the data. Always keep a gap. This value minus this value. This minus this. Select this cell minus select this cell. This is maximum minus. Or you can write is equal to max, C2, C5, minus. Is equal to median.
So repeat once again range.
Is equal to range is maximum cell minus minimum cell. Maximum cell minus minimum PAR. Bracket. You are not be doing the population sample. STDEB is equal to STDEB is equal to PAR. Plain to plain. One of the STD function. This one, all difference will be there. You might be using the older version of software. Okay, all of you done till this point? Is equal to quartile. C2 colon C5796. The moment you insert comma, you get the options, right? C2 colon C5796, comma, and then choose. Double click on the close bracket, enter. Is equal to quartile. C2 colon C5796, comma. The moment you insert comma, you get the options. Scroll down the option you want, double click the option you want, it inserts the value, close bracket, is equal to quartile. C2 colon C5796, comma, close bracket, enter. Comma 1, first quartile, comma 2, second quartile, comma 3, data array, comma 1, first quartile, comma 2, quartile, comma 3, we don't use, but we use them. And answer your questions. Is equal to Q3 minus, so IQR is 100. Control S, save the file. So the mean formula is sigma n divided by n. is equal to sum of C2 colon C5796 close bracket divided by count of C2 colon C5796 is equal to sum divided by count is equal to sum divided by, you get the exactly same. This is the formula. The manual calculation formula is this, sum divided by count. You can type small letters, no problem. Excel is not case sensitive. You can type small letters, it will automatically convert into uppercase. Sort data in ascending order. For median, what we do? Ascending order sort. So don't select price. Do not select the price. Select from C2, Control Shift down arrow. Go to Home tab, sort and filter, smallest to largest. Sort and filter, right extreme corner, you will see sort and filter. Smallest to largest. Select the data, go to the extreme right, sort and filter. Right side of extreme right, you will see sort and filter. Smallest to largest. Sorted data, right? 2n by 4. You remember? Second quartile or median is same, right? That means is equal to 2 into 5795 is equal to 2 into 5795 divided by 4. Anything. 2n by 4 or n by 2 is equal to open bracket 2 into 5795 close bracket divided by 4. So if you take it as 2897 is your median. 2897 observation is the median. 2897 is median. 2897 observation is median. Control G, 2897. Cell reference 2897 and go. Select the data range, Control G, 2897. Oh, wait, this reference is not valid. So we have to give the cell reference also, right? 2897 observation, right? C 2897. C2897. It will go to the 2897 cell, which is 120. So your median is 120. Median is 120. 2897 C. The formula is 2n by 4 or n by 2. 2n by 4 or n by 2. 2897 is your observation number, which is your median. Control G and give C2897 or whatever column you have, that column alphabet and 2897. It will go to that cell. So we have to sort the data in ascending order, n by 2 or 2n by 4. You will get the observation number. Control G, column alphabet with observation number. You will go to that particular cell. You will go to that particular cell. In Excel, the brackets are very important. Why brackets are important? Because Excel follows the power of. First, brackets, power of division, multiplication, addition, and subtraction. In our formula, we want the multiplication to happen first, 2n, right? And then the output has to be divided by 4. That's why we have to give brackets. If you don't give brackets, it will first divide and then you have to be very careful with brackets. Because in our formula, the numerator has to be calculated first. Then it has to be divided by the denominator. But as per Bodmer's rule, division comes before multiplication. So we want to do multiplication before and then division, which you can do by specifying the bracket. So brackets are very important in Excel. Okay, we will be working with advanced brackets at 2, 3, 4 like that. So that time we will understand the formulations and all, but basically understand the Bodmer's rule. Brackets of division, multiplication, addition, and subtraction. So in our formula, multiplication first, then division. That is why we have to give brackets in top. So it's 4 o'clock. We'll take a break for 15 minutes and come back. So we calculated median. Mode, we have to find out how the mode or most frequent is calculated. For finding mode, it's a little bit complex process. Copy the price column, Control Shift down arrow, Control C, paste it in a new column. Copy the data and paste it in a new column. Keep the column selected. Keep the column selected. Copy the data of price into a new column in the same sheet. Keep the column selected. Go to the data tab. On top, you will see the data tab. Home, insert, and data tab. In data tab, you will see advanced filter. You can see on the projector, advanced filter. Keep the column selected. Go to the data tab, advanced filter. Next to sort and filter, you will see advanced. Select copy to another location. Copy to another location. Click on the color box or arrow next to copy to. Select some empty cells like this. Copy to and select some empty cells. Copy to and select some empty cells. Tick mark unique records only. Click on advanced filter. Copy to, select some 5 or 6 vertical cells and tick mark unique records. These are the unique values in our data. Keep the data selected. Go to data tab. In data tab, you will see advanced. In data, you will see for Google Sheets. In data, you will see unique records. Copy to another location. Then copy to. Leave the criteria range empty. Copy to. Click on the arrow. Select some empty cells. Tick mark unique records only. Copy to select empty cells. Vertically, you have to select 5 or 6 empty cells. Just select some empty cells vertically. 5 or 6. Then tick mark unique records only. So we got the unique values. Select the column. Copy paste the column in some other location. Anyway, now select this column. Control Shift down arrow. Go to data tab. With data cleanup. Last. Remove duplicates. Okay. Now we need to count how many of them are 10, 11, 12 like that, right? We need to count how many of them are 10, 11 or there. Is equal to count if. You have to select the original data range. The D1, right? Right? Is equal to count if. It is asking for range. Range is your data range. Control Shift down arrow. Criteria. Select the value criteria cell. Now we are going to drag the formula down. When you drag the formula down, the cells will also slide one step down. To avoid this, you have to fix the cells by pressing Fn plus F4. Fn plus F4 will add two data dollar symbols to the Fn plus F4. Fn button will be there on the left side of your keyboard. Fn plus F4. Fn plus F4, or in some laptops, if it is F4 directly, it will insert dollar signs. It is called absolute cell referencing. Absolute cell referencing means even if you drag the formula, the data range will be fixed. Otherwise, the data range will move one step down. If I don't fix the formulas, we have to fix the data range and enter and double click the formula. See, for everything, the data range remains constant, whereas the criteria will change. The data range remains constant. The criteria will change for each iteration. For this, the data range is similar. The criteria needs to change. Criteria should be changing. Data range should not change. To stop it from doing that, we have to use absolute cell referencing by using Fn plus F4 or F4 directly. You can select multiple cells. Criteria you have to select this. And for that N2, go to cell N2, F1 plus F4. So that for N5 plus F4. Absolute cell referencing. Data range will not change. Close bracket. That is criteria. Data is D. Okay, also frequency. Go to frequency, Control Shift down arrow, sort and filter, largest to smallest. Expand sort selection, sort. Select the frequency column, Control Shift down arrow, home tab, sort and filter, largest to smallest. Expand sort selection. See, 120 is coming 190 times. That is why we got it as home. 120 is coming 190 times. That is why we got it as home. So the mode function will do this process in the backend. The mode function will do exactly the same process in the backend. First, it will find the unique records. Then, using the counting function, it will count the range with the unique records. So 119 is the largest. What is the corresponding price? So the mode is 100. Most frequent. So mode 120 is coming 190 times stored data. So the mode function will do this process. Count plus 6 go to data. Last data cleanup. Okay, now you got the next case we have frequency here. You follow. Okay, go to the next cell. No, below frequency is equal to CO2 empty air. Go to the original data. Column, comes nodes to the right. Go up. So, common 20 is 10. The cell name was 10. Explain the cell. Get close bracket. Now go to A2. Move your cursor to A2. A2. F1 plus F4. F1 plus F4. F4. F1 plus F4. Now you go to the cell. Go to the big side. Double click. Yes. 120 is the most frequent or most repeating. Most repeating price is 120. Most frequent or most repeating. Not paid, most repeating. So it is repeating 190 times. Most repeating or most frequent, right? So it is repeating 190 times. Followed by one time. So in the Dallas market, most offered price is $120. The interpretation we can make is in Dallas market, the most offered price is median price is also $120. Median price is also $120. And most of the properties are offering $120. So this is for your what we call understanding of the formula. Not that you will use that because we have all simple formulas here. Huh? Is equal to what will do the whole process. But the back-end process is exactly the same. Just for your understanding. Okay? But you will not use these things in real life. This we will be using the simple function. But the process is same. Be it R, Python, Excel, SAS or any software. First, it has to find unique records. Then it has to make the frequency table of the number of times it is coming. What is the formula? Sigma x minus mean whole square. X minus mean whole square divided by n minus 1 or n. Variance formula is sigma x minus mean whole square. X minus mean whole square, right? So insert a column. See, next to the descriptive statistics, insert a column. Right click on the alphabet, insert. Go to the alphabet, right click and insert. Go to the alphabet, right click and insert. Insert a column. Now we will calculate x minus mean to the power of 2. We will calculate x minus mean to the power of 2. X is the observation. These values, no? The actual data points, we call them as x. All the data points which you have in your data, we call them as x. Is equal to, select the x value, C2. Mean we have already calculated here, right? Select the cell where you have calculated the mean. Now mean is constant, absolute cell referencing. Fn plus mean is constant for all the calculation. Is equal to x minus, you have already calculated mean in the table. Select the mean, fix it by pressing Fn plus F4, shift close bracket, shift plus numerical key 6 to the power of symbol 2 is equal to open bracket C2 minus, select the cell where you calculated the average, fix it by pressing Fn plus F4, close bracket, shift plus numerical key 6 will give you the cap symbol, C2 minus where you have calculated the mean. Then the mean, move your cursor to mean, Fn plus F4, the dollar signs, Fn plus F4. Because mean should not move, right? Mean should be constant. Mean should not change. For all calculations, mean is constant. That is why we are fixing the cell. Even if we drag the formula, mean cell will not move. Otherwise, it will go to next, it will create problem. Close bracket to the power of 2, press enter. And double click the formula. Come to the bottom green, double click on your left side, it will calculate the. So this is the formula. Open bracket, observation minus mean. Fix the mean by pressing Fn plus F4. Close bracket, shift numerical key 6 will give you the cap symbol or the power of symbol 2. And double click the formula. It will calculate till the end. Okay, got the all of you? Now, next to the variance cell is equal to sum of, is equal to sum D2 colon D5796, D2 colon D5796 colon D5796 divided by open bracket 5795 minus 1 is equal to sum of the x minus mean whole square column count 5795 minus 1 where rapidly you get a big equal to open bracket. Minus 6 fix it by pressing F4. Close bracket. Now double click and set. You have come to the dot. You have come to the bottom dot and double click. Sum of the calculated column. See, your assumptions need to be included. No problem. You try to include. What is standard deviation? Square root of variance is equal to SQRT and select the cell where you have calculated variance. What is standard deviation? Square root of variance. So is equal to SQRT open bracket and select the cell where you have calculated the variance. SQRT and select the cell where you have calculated the variance. Press enter. You'll get the same value. 128792, 12787. So basic calculations, exactly whatever the textbook formula says, they are being implemented by Excel. But we can simply use the function. By using the function, same calculation will be done in the backend. Now, skewness, there are many formulas to calculate. We will try x minus mean, cube, and standard deviation. So this is the formula for skewness. Formula of skewness, which is used by Excel, is this. So first you have to calculate x minus mean to the power of 3. Insert a column next to x minus mean whole square, insert a column. Right click on the alphabet, insert a column. Next to x minus mean whole square, insert a column. Now calculate x minus mean cube. Insert on the next column x minus mean whole square, calculate x minus mean cube. Okay? And then double click the formula. X minus mean cube. Like how we calculate x minus mean whole square, here we are calculating x minus mean cube. You can see that all the numbers are negative. X is less than mean, so it will be obviously negative. 10 minus 186. Squaring will give you positive, cube will give you negative. In the earlier instance, we are squaring. That's why I got the positive value. In this case, we'll get negative. Is equal to x minus mean whole cube. Double click the formula. Mean has to be fixed by pressing F1 and F4. All right, done. Now look at the formula. The formula is, we have calculated this part, right? We have calculated the x minus mean cube part. Now we need to do the summation. Is equal to, the column is E, is equal to sum E2 E5796, sum of E2 colon E5796 divided by standard deviation. We have already calculated standard deviation, right? This is the standard deviation to the power of 3. Standard deviation cube is equal to sum of the column x minus mean whole cube divided by standard deviation to the power of 3. You got 40,397, 4,03,971. Now click on the cell, click on the formula again. We have to do the other part, right? Click on the formula again. Shift 8 into continuation of the formula. Open two brackets. Select the count 5795. What is n? Close the first bracket. Divided by 5795 again. Minus 1, 5795 minus 2. Close two brackets. H2 divided by H2 minus 1 into H2 minus, oh, I made a mistake in the brackets. Is equal to 5795 divided by 5795 minus 1, 5795 minus 2. Correct? I'm getting it wrong. Into H2 minus 2 is also there, no? This is the problem with brackets in Excel. Yeah, done. 1 second. Let me move the image to the side. N by n minus 1 into n minus 2. N is 5795. Not that you need to remember the formulas. To understand the basic statistics, we are doing that. But you need to remember the function is equal to SKEW. And then what is given the arguments. Only numerical data. Follow the color coding or 75 will get the cutoff is the same, but you have to give 4. Instead of cube, you have to give 4. That's the only difference. Cutoff is. See, skewness, I told you, the graph. How your data, see, in statistics, distribution is very important. You know, distribution, right? Normal distribution is one type of distribution. We have S-shaped curve. We call it as binomial distribution. We have something called Poisson distribution. So there are different distributions in statistics. Normal distribution is one of the most important distribution when you are studying in numerical, when you are studying or when your dependent variable or when your target variable is numerical and it is continuous, then we have to have an assumption called data must be closer to normal distribution. Now, by plotting the skewness, we will know. Now here it is very high. 69 is very high, right? Skewness we want as much as closer to 0. We want skewness as much as possible closer to, but in reality it doesn't happen. This is a real-time data, always has high skewness. And when you have high skewness, multiple linear regression will not work. The base model or the fundamental algorithm in regression is multiple linear regression. Multiple linear regression is a fundamental regression algorithm in data science. That algorithm will not work because of skewness. Because one of the assumptions of that algorithm is data must be closer to normal distribution. But is that the case here? So that algorithm will not. So what we have to do? We have to go to advanced algorithm like decision tree, random forest, gradient boosting, neural networks, which are not affected by. So there are different algorithms. So we need to decide which algorithm to use when. That decision can be made using this descriptive statistics. Now, this statistics as of now is telling I cannot implement the base model called multiple linear regression, which is the first model we will do in data machine learning. His first model is multiple linear regression. So I come to know from this descriptive statistics that algorithm will not. So I'll go to the next level of algorithms, which is decision tree algorithm, which is not affected by skewness. Random forest, which is not affected by skewness. K nearest neighbors, not affected by skewness. So that's how we need this descriptive statistics. So I'm coming to an understanding that my price variable. So in this data, what can be our analysis variable price? Because how will customer decide where to go, which room to buy? So price, afterwards, we will look at the reviews. Generally, that's what we do now. When you're trying to book hotels online, first we look at the price, then we look at the reviews. So price is our critical variable. Price is our analysis variable. We'll study that variable. We are studying that variable independently now. We will study it along with reviews. We will study it with categorical variables like room type. We will study it with variables like neighborhood, categorical variables. So you can study the price aspect with combination of different. Ultimately, you have to generate intelligence or information that helps the management to make it. So the management wants to understand the Dallas market. They want to increase the bookings in Dallas market. So they want to study the price patterns. They want to study the booking patterns. They want to study all the advanced patterns or trends in that particular data. And then they will use it for doing advertising or giving offers, promotions like that. They will do for increasing the revenues for the company. You can also do them in Power BI. Same things can be done in Power BI also, or a Tableau. Tableau or Power BI will also give you the information. But you can also add graphs there. We will also have graphs in Excel also. There, it's just drag and drop, do some basic calculations, quick measures and all. We'll get the same information. We'll create a dashboard for the management. This is the Dallas market. Then they will decide how to increase the revenues for both the company as well as that is what we have to understand. So these descriptive statistics will give us a lot of information. Two things we can observe on this descriptive statistics as of now. The mean and median are distant. Standard deviation is high. Standard deviation thousands, right? Most of the rates are in hundreds. If you look at our unique counts, most of the rates are in $10, $20, $100. Very few are in $1,000. You look at the frequency table, right? Most of the rooms are in which part? You don't see any $1,000 here. Most of the prices are in hundreds of dollars or tens of dollars. But the standard deviation is coming as 1,000. Why? Because we have extremely high valued properties. We have some extremely high valued. If you scroll down, you will see the high value properties, right? We have some thousands, 500, 600, see, 1,000, 1,000, 1,000. These are the problem properties. Only one property is there, but they are distorting our, like only 2 students created a problem there, right? How many thousand above properties are there? Very few. One property is 95,247. This is definitely the problem. Skewness indicates outliers. That means there are extreme values. The tail represents extreme values. Normal range. See, normally all the values are between $10 to, but you have certain values which are from $300 to $95,000. So the tail will be very, very, and the peak will be onto the head. So that is the problem. You can do the histogram here only. As I says, kurtosis peak, whether it is a narrow peak or kurtosis means positive means there are too many positive values. Negative means too many negative values are there. Also. See, the only single bar is coming. If I draw a line like this, it will go like this, right? Narrow, one single tall peak, narrow. Right. So that is how we'll come to know. Why it is not coming? See, frequency we have done. Even the box plot is also suggesting it's a very, box plot is also saying it's a very narrow outlier is there, no? That is the problem. See, the analysis is we want the data to be as much as possible closer to normal distribution. So our graph will be like this, very narrow, not even this peak, very, very narrow peak will come. Our data will be very, very, or let me show you correctly how it looks like. See, single tall bar. So if you are looking at density, it will tell you how close it to normal distribution. Is it close to normal distribution? This is not close to normal distribution, right? And very high kurtosis. If we do logarithmic transformation, I have not imported numpy. See, this looks better, right? The original data was very, very skewed and very, very thin. This looks to some extent some change. We can't eliminate completely skewness and kurtosis. We can only minimize them. So I have taken the log values instead of the actual values. I have taken the log values, natural logarithm, basted it. NP.log means natural logarithm. I have taken the log values instead of the actual values. I calculated log of 10, log of 20 price thing, then I plotted them. So now you can see this is to some extent closer to normal distribution, to some extent, but not thing. But still the kurtosis is very high. See that narrow peak. So these sort of transformations we have to do when you're working in machine learning model. That time we will discuss ML models and all. We will discuss these things, how we have to transform the data so that it can be fitted to a model. Right? Okay. So that time we will see. So for a basic understanding, just showing how important it is. So this data is presenting high skewness and high kurtosis, which can be corrected using logarithmic transformation to some extent. Got it? So these are certain rules which we need to implement, follow in statistics. Okay. Then there are certain remedies also available for that problems. Sometimes they will work, sometimes they don't work. Yes, it is very high, na? 5,127. That is why you get a very pointed peak, narrow peak. Pointed peak is there. Understanding of this statistics. So all of you copy column L, use Excel functions only to calculate. Number of reviews. Copy paste the number of reviews into a new sheet in the same workbook and calculate all the descriptive statistics. We have a basic stats exam in third week of the third week of the statistics exam will be there, covering descriptive statistics, hypothesis testing. And then we will do both in Excel. It will be MCQ. Chandana and Priyanshu, can you give your email address, please?
Chandana Bandaru, sir.
Type it in chat. Priyanshu, you are there. You will also give me your email ID because I have to add it to the drive. All of you check, you got the drive link.